Hello everybody, another day, another dollar, or in my case nothing because I don't make goddamn anything making these videos. Last week we began touching on some of the different types of proteins that do not perform enzymatic function. Unfortunately for you all, there's one more that is also necessary to know, and is also maybe the longest, maybe the hardest. Now before I hear too many moans and groans, these ones are pretty damn cool. Yes, I said something in biology is cool. If you don't find anything interesting, then you're better off quitting and becoming a stripper or making an OnlyFans of yourself acting like a dog. Yes, that is real, and no, I am not subscribed. The last sect are called ion channels. They are what they say they are. Channels that allow charged molecules to pass through the cell membrane down their concentration gradient. For my chemically challenged friends, from an area of high concentration to an area of low concentration. These molecules could not pass through the membrane without these ion channels, as the molecules are usually fat, angry, or coked up. For my PC watchers, large, polar, or charged. The first type of ion channels are ungated, and fuck do these things rock. They are as regulated as prostitutes in Las Vegas, meaning not at all. They allow ions to get to equilibrium without requiring any extra steps. This is as easy as it gets for ion channels, so buckle up because the other ones are a little bit more complicated. The next are voltage-gated channels, which are regulated specifically by the membrane potential. They are normally closed, but membrane depolarization causes a conformational change that allows them to open. Depolarization does not have anything to do with climate change, so don't even fucking ask. With that being said, save the penguins. It has to do with less negative charge inside the cell, creating an imbalance. Ions flood into the cell until the membrane is repolarized, and they quickly close. It is like a bar. Opens, people begin to flood in, then the doors are quickly closed when capacity is reached. Finally are the ligand-gated channels, and they're pretty fucking easy. Just a substance or ligand binding to the channel, causing it to open. It does not require much explaining on my part, so I'm just going to move on to the next thing, because it gets a little crazy. So I did kind of lie to you. I'm not really sure why you decided to trust me in the first place, because I don't really know you from any Tom, Dick, or Harry walking down the street, but there is another part to signaling, involving proteins called G-protein coupled receptors. They are involved in signal transduction via adenylate cyclase. Yuck. And it gets weird, so as per usual, I'm going to dumb it down to the best of my ability. A molecule binds to the G protein in the membrane, and signals are transmitted in cells using a heterotrimeric G protein, meaning there are 3 different proteins. Come on, fucking inbreds. GS stimulates adenylate cyclase, raising CAMP levels. GI inhibits, lowering CAMP levels. And GQ activates phospholipid C, which cleaves a phospholipid from the membrane from PIP2, which is cleaved into DAG and IP3, blah, 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 blah. It's so boring I can even barely keep my eyes open reading this. The important thing is that IP3 is used to make calcium channels for the cells to be able to take calcium up. Now that we are through proteins, we can relax. Maybe make a pina colada, kick back, and just tie one on. Well, I'm kind of kidding here because there is one more section we need to go over. This one involves isolating all the proteins that we just spent so long learning. At the base level, tissues are crushed, grinded, and blended into a mixed solution. Not something you're going to want to take a shot of. A centrifuge can be used to separate the proteins from one another in solution. Now this is some freshman year Bio 100 bullshit, first lab ever, all horned up to get started. But trust me, it gets a little weird when you're tasked with isolating specific proteins. The first technique is called electrophoresis. Basically, it is putting protein into a polyacromide gel, connecting it to an electric field, and moving them a certain distance according to size and charge. The gel also acts as a sieve, so larger molecules have more trouble traveling through than smaller molecules, like a caulk on a casting couch. I really hope that this doesn't come to a surprise to anyone, or else we might have some psychological issues in play. But the negative proteins migrate toward the positive cathode, and vice versa. The velocity of the migrating protein is calculated by the equation V equals EZ over F, where E is electric field strength, Z is the net charge on the molecule, and F is a frictional coefficient. Yes, there's a tad bit of math, but it's not like you're taking integral, so relax, Einstein. There are 3 main types of electrophoresis: native page, SDS page, and isoelectric focusing. Fuck, that voice crack was bad. Native page is the easy one. Just separates proteins based on their native state. Unfortunately, it cannot be as simple as mass to size and mass to charge ratios, because that can cause different proteins to migrate the same distance. This is where our SDS page comes to save the day. I'll say it quickly. SDS stands for sodium dodecyl sulfate. Now, you can forget that because it's not really important at all. SDS is added to disrupt the covalent bonds in proteins, neutralizing charge, and denaturing the protein, allowing it to be analyzed on mass alone. The last is separation based on isoelectric point. Dig back into your brains somewhere, keep looking, no, ignore your first boner, and find what isoelectric point means. For those who don't know, this is the point where an amino acid is electrically neutral. Isoelectric focusing works by separating proteins based on where their isoelectric point falls. The protein is placed in a gel with a pH gradient, with positive proteins moving toward the cathode, higher pH, and negative proteins toward the anode, lower pH, when an electric field is applied. When a protein with an isoelectric point at pH 10 is in a gel at pH 4, protons attach to the basic points and it will migrate towards the cathode until it reaches a pH of 10 where it will stop. The last thing I need to touch on, like a priest in the 1970s, is chromatography. The basis is that the compound that is more similar to its surroundings will move more slowly through its surroundings. Now this sounds like some deep Freudian shit, but it's not, and I'll break it down. A sample is placed into a solid medium, called the stationary phase, and a mobile phase is run through the stationary phase. The sample begins to elute, a fancy pretentious word for the sample running through the stationary phase. The distance traveled is dependent on the affinity the sample has for the stationary phase, and is called its retention time. This process allows separation of different compounds of a sample. There are 4 main types of column chromatography that we are going to power through, like drunk Taco Bell at 3 a.m. Column chromatography is the first one, and it involves silica or aluminum beads as the stationary phase. The mobile phase moves through the stationary phase, depending on the size and the polarity of the sample, as the less polar tends to elute faster. Now, this one is like crack for chemistry professors, so they're probably going to make you do it almost any chance that they get. Ion exchange chromatography is well suited for charged substances. The anal beads, just regular beads, in a column will attract and hold proteins of the opposite charge as they flow through. It is then washed out and removing all sample that is not stuck to the column. Size exclusion chromatography is probably the easiest one because it literally says what it's separated on in its name. Similar to ion exchange, the sample is run down a column but with pores of various sizes. Large components cannot fit in the pores and travel through faster, while smaller components are slowed down. The last is affinity chromatography. This one's a little bit special because it's pretty much dealer's choice when it comes to how they want to separate proteins. Beads are coated with specific receptors that allow proteins to bind to and be retained in the column. Once retained, the column can be washed with a free receptor to compete for the proteins, allowing some of the sample to be washed out. Well, that's just about all I got for you this week. Next week we will be doing, I have no fucking idea what we're going to be doing next week. Maybe carbs, maybe lipids, I don't know. I really want to get through all this biochemistry stuff because it can be a real drag, so keep sticking with it and we'll try to get onto some more fun information in the future. As always, like and subscribe. Feel free to roast me in the comments and have a good week, motherfuckers.